NASA's Lunar Trailblazer mission. What happened? Imagine the excitement of a groundbreaking lunar mission coming to a sudden halt. NASA's Lunar Trailblazer mission is a prime example of this. More than 5 months after losing contact with the smallsat, the space agency has officially called it quits on this lunar orbiter project. This setback is yet another challenge in NASA's ongoing efforts to conduct cost-effective planetary missions. To continue reading this article, register now and get 3 free articles every month. You'll also receive our weekly Space News This Week newsletter every Friday. Opt out at any time. Sign in to an existing account. Get unlimited access to spacenews.com now. As low as $5 per week. Cancel anytime. Sales tax may apply. No refunds. Billed quarterly. See all subscription options. https://subscribe. But here's where it gets controversial. Why did NASA decide to abandon the mission after losing contact? Was it due to financial constraints, technical issues, or a combination of both? And this is the part most people miss. The Lunar Trailblazer was designed to be a low-cost, innovative approach to lunar exploration, aiming to map the moon's water-ice distribution. Its premature end raises questions about the viability of such smallsat missions in the face of unexpected challenges. Jeff Faust, a space policy expert and frequent contributor to Space News, delves into these issues. With a PhD in planetary sciences from MIT and a background in geophysics, Faust brings a wealth of knowledge to the table. He explores the implications of this mission's cancellation and its potential impact on future lunar exploration efforts. Post-navigation. This incident underscores the inherent risks in space exploration, where even the most meticulously planned missions can face unforeseen obstacles. As we look to the future of lunar and planetary science, it's crucial to learn from these experiences and adapt our strategies accordingly. What do you think? Should NASA continue to invest in smallsat missions despite the risks, or is it time to reassess the approach? Share your thoughts in the comments below. NASA's Lunar Trailblazer mission ends in disappointment. The recent conclusion of NASA's Lunar Trailblazer mission has left many space enthusiasts feeling disheartened. Officially wrapped up on July 31st, this mission did not unfold as intended, marking a significant setback for the esteemed space agency. It is important to note that the disappointment stems from the fact that communication was lost with the satellite shortly after its launch, which occurred several months earlier. Specifically, the Lunar Trailblazer was a part of the IM-2 mission executed by Intuitive Machines. This mission took off aboard a SpaceX Falcon 9 rocket from the historic Kennedy Space Center on February 26th at precisely 7:16 p.m. Eastern Time. The satellite's separation from the rocket took place flawlessly about 48 minutes post-launch. It was at 8:13 p.m. Eastern Time that operators located in Pasadena, California, successfully established contact with the satellite, only to find that two-way communication was tragically lost the following day. Despite efforts to re-establish the connection, the team was unsuccessful. Preliminary data received indicated that the satellite's solar arrays were not adequately aligned toward the sun, leading to a critical battery drain. Nikki Fox, who serves as the Associate Administrator at NASA Headquarters Science Mission Directorate, expressed her sentiments regarding the unfortunate outcome, saying, "While it was not the outcome we had hoped for, experiences like Lunar Trailblazer provide invaluable lessons that help us reduce risks for future, low-cost, small satellites aimed at conducting innovative science as we work toward establishing a sustained human presence on the moon. I would like to extend my gratitude to the Lunar Trailblazer team for their unwavering commitment to this mission and their dedication to learning from every aspect of it until the very end." Looking ahead, the Lunar Trailblazer mission was just one of several that are expected to aim for the moon by 2025. It was designed with the ambitious goal of developing high-resolution maps to identify the presence of water on the lunar surface, examining the quantities and forms of that water, as well as how it may have evolved over time. Let's remain optimistic that the upcoming missions will yield more favorable results. But it raises a pertinent question. What lessons can be drawn from this setback? And how can we ensure that future lunar missions navigate these challenges more successfully? We'd love to hear your thoughts on this. Do you agree or disagree with how NASA has handled the situation? NASA Lunar Trailblazer moon mission ends. What happened? What's next? When a mission to the moon ends before it truly begins, it leaves both scientists and space enthusiasts heartbroken. NASA's Lunar Trailblazer mission met this unfortunate fate on July 31st, after months of efforts to salvage communication with the spacecraft failed. But here's where it gets controversial. Should high-risk missions like these still be pursued if they can yield groundbreaking discoveries? Let's dive into what happened and why this loss matters deeply for lunar exploration and beyond its practical applications. The mission aspired to deepen our understanding of water cycles on airless celestial bodies throughout the solar system, an area of study with profound implications for planetary science. Lunar Trailblazer shared its launch with Intuitive Machines' IM-2 robotic lunar lander mission aboard a SpaceX Falcon 9 rocket. The launch took place on February 26 at 7:16 p.m. Eastern Standard Time from Florida's Kennedy Space Center. About 48 minutes later, the small satellite separated successfully from the rocket, marking the beginning of its journey toward Earth's natural satellite. Mission operators at Caltech's IPAC facility in Pasadena briefly established contact with the spacecraft shortly after separation. But tragically, communications were lost just one day later. Without two-way communication capabilities, the team couldn't diagnose or correct critical issues affecting the spacecraft's trajectory. Specifically, data suggested that Lunar Trailblazer's solar arrays weren't properly aligned with the sun, leading to depleted batteries. As weeks turned into months, teams around the globe, including volunteers, worked tirelessly to track the spacecraft using ground-based radar and optical tools. Observations indicated that the craft had begun spinning slowly while drifting further into deep space. Andrew Klesch, the project systems engineer at NASA's Jet Propulsion Laboratory, JPL, expressed hope during this challenging period. As Lunar Trailblazer moved farther away, models showed that sunlight might eventually reach the solar panels enough to recharge the batteries, he explained. This possibility kept the team optimistic, but ultimately, the growing distance made recovery impossible due to weakening telecommunication signals. Despite the setback, the technological legacy of Lunar Trailblazer lives on. Its instruments, including the High-Resolution Volatiles and Minerals Moon Mapper, HVM3, and the Lunar Thermal Mapper, LTM, represent cutting-edge advancements in space technology. While HVM3 was developed by JPL to map water and mineral deposits, LTM, constructed by the University of Oxford and funded by the UK Space Agency, focused on gathering temperature data and analyzing silicate compositions. Both instruments aim to provide vital clues about the moon's dynamic water content. Bethany Ellman, the mission's principal investigator at Caltech, reflected on the outcome with resilience. Though we're deeply disappointed that Lunar Trailblazer didn't reach the moon, the expertise gained and technologies developed will benefit other projects, she said. In fact, some aspects of the mission are already being repurposed. NASA recently selected an instrument similar to HVM3 for a future orbital flight. This new tool promises to deliver unprecedented spatial resolution data on lunar water and minerals. So what lessons should we take from this experience? Nikki Fox, Associate Administrator of NASA's Science Mission Directorate, emphasized the importance of embracing calculated risks. High-risk, high-reward missions like Lunar Trailblazer push boundaries and teach us valuable lessons for future endeavors, she stated. And this is the part most people miss. Even when missions fail, they contribute significantly to advancing space exploration. Now comes the thought-provoking question. Do you think the potential rewards of such daring missions justify their inherent risks? Or should NASA focus solely on lower-risk endeavors? Share your thoughts in the comments below. We'd love to hear your perspective.